as per the instruction of an ATAL. So each and every session is get recorded. Uh, Sir, shall we start the session, sir? HOD, sir.
Madam, screen will visible, madam?
Sir, yes, sir. Your screen is
Oh,
visible. Just to give a
okay.
slideshow.
Oh, okay, madam. Okay, thank
Okay,
you.
sir. We'll start a session. First of all, I welcome everyone. It is a great honor and privilege of welcoming our resource person, our HOD, head of the Department of Electrical and Electronics Engineering Department. He has completed his BE Electrical and Electronics Engineering from Alagappa Chettiar Government College of Engineering and Technology, Karaikudi, and he completed his ME in the field of power system from National Institute of Technology, Trichy, and he completed his doctoral degree from power system from Anna University, Chennai. He has 2 years of industrial experience and more than 25 years of academic experience. He is an approved supervisor, research supervisor. He got an recognition from Anna University, Chennai, and also Karpagam University, Coimbatore. He had completed guided one candidate and now guiding two candidates. He has published 24 papers in various national and international reputed journals and presented 36 papers in various national and international conferences. He has submitted a survey report on transmission and distribution laws of Tamil Nadu grid to TNEB through FICCI. He has published 4 books on the title of Circuit Theory, Basics of Electrical and Electronics Engineering, Fundamentals of Electromagnetic Fields, Basics of Electrical Engineering. He had delivered lectures in ATAL FDPs, AACT STDPs, Anna University FTPs, and FICCI Energy Panel and various engineering colleges. His area is interested electric vehicles, power system, and fax controller. It is a great honor of welcoming our resource person, our head of the department, Dr. P. Silvam, sir. Sir, I welcome you, sir.
Thank
I
you,
hand
madam.
over the session to Silvan, sir.
Thank you, madam. Thank you for your kind introduction. Thank you, madam. Very good morning to all the participants. First, I would like to thank the management and our principal and the coordinator of the ATAL Faculty Development Program on challenges and opportunities for electrical vehicle adoption, Dr. Shyamala madam, to provide me the opportunity to deliver the lecture on the introduction with the EV technology and electrical vehicle configuration, the working of the electrical vehicle, and also the configuration of the components and its function, and finally the vehicle and grid communication and coordination. This program is jointly organized by the internal quality assurance cell of our Erode Engineering College and the Department of Tripoli. So before going to the topic, the recent topic and also advanced topic in the automobile, the first and foremost reason to conduct this kind of FDP, the Faculty Development Program, is to learn the new technical tricks of electrical vehicle segment and also the policy support and the potential of electrical vehicle market in India and the world. So definitely this FDP is especially good for learning about how the electrical vehicle companies and projects approach their work. This perspective can help to assess strengths and weaknesses and give you the better sense of what position you occupy in the larger field of electrical vehicle. So the FDP is a great forum to learn about the upcoming legislation and the organizations that are keeping an eye on development in the electrical vehicle that affect both the community and also broader technical industry. Next, the electrical vehicle segment in India has gathered the great momentum in recent years, that is the early 2020s, but a mismatch in intent and action has resulted in limited on ground adoption of the electrical vehicles for so many reasons. So however, the expected growth of the automobile sector, especially in the personal mobility, due to the ongoing COVID-19 pandemic, the people are increasing the understanding of the vehicular emissions and also creates immense scope for the exponential growth of the electrical vehicle industry in India. So essential decisions is needed and investments are required to facilitate these kind of electrical vehicle advancement. And even as the government introduces a stimulus-based investments to mitigate the fallout of the pandemic, the electrical vehicle sector must be a beneficiary one. Next, it explores, that is, electrical vehicle explores major factors and it affects the evaluation of the personal mobility from 2020 to 2050. The scenario-based approach, a diverse study team of faculty, researchers, and students examined how different factors shape the future of personal mobility at different scales, from global and national markets to policy and mobility choices as a city and individual level. So this FDP presents results and findings to help the stakeholders like the automobile sectors anticipate and navigate the challenges that lie ahead. Next, the India electrical vehicle segment has grown only in the recent years. The pace of such growth, however, has been slow. The policy support has been insufficient for realizing the full potential of the electrical vehicle market. So the sale of electrical vehicle remains low because when compared to internal combustion engine. So according to our industry data, the equipment sales, the financial year you have seen in the financial year 2015, it's around 16,000 vehicles is sold out, but it includes both two-wheeler and four-wheeler and the tri-wheeler also. But the increasing in manner, the financial year 16 it is 22, financial year 17 is 25,000, increasing in financial year 20, it may around 1,50,000 electrical vehicles sold out in India. So it shows that the electrical vehicle is most important, predominant in the automobile sector. So electrical vehicles sales in India mostly driven by the electrical two-wheeler and three-wheeler only, not for the buses like that, because the electrical buses are available and sold out only in the year 2020. So the four-wheeler segment is still small. So to face this
Sir,
segment, yes, madam.
sir, PPT
I will
change
like to
agla.
show it, madam. It's introduction only. After that,
Okay,
only
okay.
go to the content. The
Okay,
introduction.
sir.
So this is the four-wheeler segment is very still small. So we can increase the sales of the electrical vehicle in four-wheeler also. This is considered the shortcoming of the electrical vehicle manufacturing and the sales and all. So with this introduction, so what is the content we are going to this introduction of the EV technology and the electrical vehicle configuration and the working of electrical vehicle. Next, the fundamentals of motor components and its functioning. The finally the vehicle and the grid communication and the coordination. So the path to post-COVID-19 recovery is not clear and going to be difficult one. So the government is taking measures to save lives and to provide immediate relief, but will have to engage in many longer-term revival measures. So the electrical sector has only just started to move towards its potential in India and the light of the COVID-19 outbreak. So next we go to the content of the today's session. So first, before going to this, what is the historical background of the electrical car? So the electrical cars and the electrical vehicles were prevalent in the early 20th century when electricity was preferred in automobile propulsion. Even the electrical vehicle sales are very less because due to advances in internal combustion technology and also especially in the electrical starter, then the greater range of gasoline cars, that is a fuel vehicle, then quicker refilling times and a growing petroleum infrastructure and also mass production of the gasoline vehicle with reduced prices, and also it will give the less of half of the rate than compared to the electrical cars, which lead to decline of the electrical propulsion. But the increasing of the electrical vehicle, it is in the year of 1970s, 80s, it is due to relevant interest in electrical vehicle because of the energy crisis. The further, the global economic recession in the late 2000s, the abundant fuel inefficient SUV, that is a sports utility vehicle, it favors the electrical car, hybrid cars and small cars. The next, how the electrical vehicle step by step it is coming into the world in the 1830s. You know, the first electrical vehicle, that is electrical car, invented by the Thomas Davenport and the Robert Anderson. They are using the non-rechargeable battery. It is the first large-scale operation in the United States automobile industry. The company that developed the first electrical vehicle is Pope Manufacturing Company in America. Next, the continuation of this, for 60 years it dominating, and after 1890s, all electrical vehicles sold out the gasoline car. That is the fuel car. It's a 2:1. The Oldsmobile and Studebaker started an electrical vehicle company. Then 1904, the first speeding ticket. What is the speeding ticket? So the electrical car run for the more speed, that is 8 km per hour. This allowed speed at the time it is 2 km per hour. So they are giving the speeding ticket to the driver of an electrical vehicle. That car is developed by the Chrysler company. This is the first hybrid electrical vehicle. Next, in the year 1910, the mass-produced Ford car, that is electrical vehicle, with mass-produced in the sense they are producing the car with a lesser time. At the time they are producing the car with manufacturing and assembly, it will take 12 hours. But the mass-produced Ford car, they will take only the 1 hour 33 minutes to assembly the single car. So it is the first electrical vehicle of the Detroit Electric Company. The next continuation of this, next electrical car by Siemens Company. Next it is another car with the Detroit Company. This is figure shows the Thomas Edison is with the car made by the Detroit Electric. It is developed by the Anderson Electric Car Company, Michigan. Then 13,000 car produced during this year, that is 1907 to 1939. So 13,000 cars they are produced and sold out by the time. So continuation of this, 1902 and 1919, Tribal Horn, another car, it is a Swiss-based electrical car. There they produced both 3-wheeler and 4-wheeler. And also they developed the electrical truck, that is a trolley truck like electrical train. And 1961, another development of the electrical vehicle is called Kenny Kilowatt. It is a US-based company. They are developing this, they are manufacturing car with combined with a Renault Dauphine. That is a Renault company, you know, nowadays. Next, it is a top speed car, the version of the electrical vehicle, that is a 60 km per hour it is running. By this company, they are manufacturing only 47 cars. They sold out 45, the 2 in the museum now. Then next version, it is a 1974 to 1977. One car, Sebring city car. What is the city car? It is a 2-seater car, 2-door car. It is a Florida-based Sebring car. It is developed. The next generation is a 1996 Saturn electrical vehicle 1. It is developed by the General Motor. It is a US-based company. The other name of these cars, it is given. Next. You know the Chevrolet, it is a recent car type. It is a Chevrolet Volt also, it is a one type of electrical vehicle. It is developed by also the General Motors. The other name of this Chevrolet car is called a Bucky vehicle and a Holden Volt. So the Holden Volt and Chevrolet is combinedly manufacturing this car, so that it is called Chevrolet Volt. Then 2008, Tesla company, they are developing the car, that is a Tesla Roadster. In 2008, it is the all e-battery powered vehicle. This is not a hybrid vehicle. It is a fully electrical vehicle, and also it is also running by 60 km per hour. The advancement of the electrical car, it is a solar electrical vehicle. Then Ford Escape hybrid. The Ford Escape hybrid, it is a 2021 model. It is a new model. The Chevrolet Volt hybrid, it is a developed. They are changed this name as Bolt electrical vehicle, and also they are planning to release in the year 2022. So these are all the history of the electrical vehicle from 1830 to present. The other type of electrical vehicles available, that is a locomotive, that is electrical train, then golf cart. Another one is called the vehicle, it is used in the train to equip the handicapped passengers, then forklifts, then buses we are running, but it has a very less number. It is only developed in the year 2020. Then electrical principle used with the nuclear submarines and also elevators. So various kind of electrical cars shown here. It is a hydrogen fuel cell. The hydrogen fuel cell, we are getting the electrical energy from chemical energy. The conversion of the chemical energy into electrical energy. This is a solar based car. The hybrid car, it is a fuel engine and also along with the battery. It is like auto. This is the combination of the loading vehicle. It is a full size battery. So these are all the various kind of electrical cars available in the world. The next, coming to the main topic here, what is an electrical vehicle? How does it work? The why electrical vehicle coming into the scenario? It is only due to the increasing automobiles and also the declining of the oil reserves, that is the fossil fuel, and also increasing greenhouse emissions to decrease the carbon dioxide emission, and also global warming. Under the CARB regulations, that is the California Air Resource Board, they will have some limitations in the emission. Having all these factors, we have to improve the existing power system efficiency. We go for alternate fuel, that is called electrical power. So again, the continuation of the electrical vehicle, it is a road vehicle based on the modern electrical propulsion. So we are getting the electrical propulsion from using motor. So consisting of electrical machines, that is a motor, the power-electronic converter, then electric energy source to run the motor, and also auxiliary source to run the various equipment in the electrical vehicle, and also storage device like the battery, and the electronic converter to control the inputs. Also the electrical vehicle, it is a broad concept, that is a battery electric vehicle. It's a pure electrical vehicle. Next one is called HEV, hybrid electrical vehicle. It is both a combination of the fuel engine and the electrical vehicle. The third one is called a fuel cell electrical vehicle. It is the pure electrical vehicle, but the energy coming from the chemical energy. So when you go for the electrical vehicle, definitely it is possible when the regenerative braking. That means during braking we can get the energy from the braking loss. It will be fed back to the supply. Next, the electrical vehicle is not only the vehicle, but it is a new system for the society's cleanliness and also the pollution-free and also efficient road transportation. It is an intelligent system which can be integrated with the modern transportation networks. That is, the communication is possible, and also it involves more integration of art and engineering. So the more advancement we have to be done to reduce the price very less, because then only the people can make them affordable to buy the electrical vehicle. So these are all the challenges in the electrical vehicle. Next, electrical vehicle composition. What are all the parts in the electrical vehicle system? There are three parts. One is electrical propulsion system, another one is energy sources, the third one is auxiliary power system. What is electrical propulsion system? It has to generate the necessary power to the wheels. That means the wheel, we need the rotational power. That rotational power through transmission we are getting from the motor. For motor, it will be run through the electrical supply, that is called the electrical propulsion system. And also it includes, it controls the level of voltage applied to the motor, that is the controller. Next, the energy source, that is electrical energy source only we are dealing with an electrical vehicle. If it is a normal automobile, we can have the fossil fuel, etc. If it is electrical vehicle, it can generate electricity or accept the electricity either in the braking. So next, auxiliary power system. That means it supplies the power to the either AC, fan, lighting system, wiper, so many extra items. It is run by the electricity. This is called the auxiliary power system. The auxiliary power system, we are having the less voltage level, it will be getting from the controller. Then next, how the electrical vehicle work. You know that the electrical vehicle is powered by electrical motor only, rather than gasoline engine, that is the fuel engine. Electrical motor gets power from the controller, because controller only gives the controlled voltage level or power level to get the desired speed. And also the controller is powered from an array of rechargeable battery. Next, this is the overall block diagram of the electrical vehicle concept. You know that here you see the traction batteries. The charger will charge the battery. Through this battery, how much voltage is given to the motor to get the desired speed. Here the traction battery gives the supply to the DC-DC controller to the auxiliary battery. It is suppose here the battery may have the 300 volt, 200 volt, whatever it may be. The auxiliary battery it have a 12 or 14 volt battery. So DC to DC converter, it will control the voltage and shape the DC voltage. It's stored in the auxiliary battery. The voltage level desired by the motor controller, that is actuated by the speed pedal. According to the speed pedal, the voltage level goes to the motor. So depending upon the voltage level, the speed, that is rotational, otherwise it is called the torque, will be given to the wheel through the transmission system. This is a simple diagram. The battery voltage given to the motor through the speed pedal control, and also the battery to the auxiliary battery through DC to DC controller for auxiliary voltage. That is a less value of voltage. Next, what are the other components of the electrical vehicle is called the motor. The motor, we can have the two types of motor. One is called AC, another one is called DC motor. The earlier, we are using the DC motor. It is runs on a voltage ranging between 96 to 192 volt. But DC motor installation is very simple. It is a two-wired system, and also it can be overloaded up to 10 times. But if you are overloading with more than 2 to 3 times, it can get heat built up, so it will reduce the lifetime. So having these disadvantages in DC motor, and also more advantages provided by the AC motor, like the better torque and the speed output, and also for same weight and size, the AC motor provides the better performance. So we are go for the AC motors. Here the electrical vehicle, the forklift motor is mostly used in the electrical vehicle, and also the dielectrical car motor also is used in the electrical vehicle. So both AC and DC also use regenerative braking. It is mostly advantages in the electrical vehicle. Next part is called controller. Why you need the controller? The controller only control the motor speed. Accordingly, the vehicle speed will be controlled. Here, the pedal. The pedal will be connected to the potentiometer. The pedal decides how much voltage from battery to motor flow. So depending upon this pedaling action, the voltage level can be controlled. This DC to DC converter, this DC controller, if it is 0 to 96, lower and higher value, we can get the average value of 48 voltage. Here we are using pulse width modulation techniques. We are using by adjusting the turn on or turn off condition, that is a duty cycle of the converter we are used, that is a devices, that is thyristor, we can get the average voltage. If you are increasing the on time, we can get more average voltage. We can decrease on time, we can get the less average voltage. So if you are programming like that, we are changing the on time of the thyristor, that is a power electronic devices in the controller, we can get the average voltage from whatever the value will be. Similarly for AC controller, for DC controller, it is a diagram. Again for AC controller, if you are the AC controller, similarly we can have the pedal action, that is a potentiometer control. Here we can distribute the voltage from here to controller to the AC motor according to the potentiometer position. This potentiometer position decided by the pedaling action is just like the accelerator. So again it will be given to the transmission system to run the wheels. So if you are using AC motor, if it is AC controller, we can use. Again the AC controller in depth diagram, you know that AC controller, it will be changing the voltage, that is a 300 voltage DC to 240 volt AC or through the inverter. You know that inverter, it is a 6 pulse devices we are using pulse width modulation. The next part of the electrical vehicle is called the batteries and chargers. So what battery we are mostly used in the earlier, it is a lead acid battery. It's a cheaper one, it is a something good in the performance. But it is a most weak link in the electrical car. Suppose if the battery is not performing well, definitely it will, the reliability of the electrical vehicle, it is a question mark. So even the battery, it has a heavy size, bulky, and also limited capacity. The another parameter is a charging rate. If it is a slow charging rate, if the life is very short and also expensive. So we go for good battery with a long life and a fast charging and a heavy life. So we can go for the nickel metal hydride battery. It will give the double the range. That means and also the charging rate is very high, and also it has a minimum 10 years of life, but it is most expensive. But even in the expensive, we can, reliability of the electrical vehicle battery, nowadays they are lithium ion and nickel metal hydride batteries are likely to be used, even though it is prices are very competitive with the lead acid battery. You know the lithium ion and the lithium polymer metal hydride battery, the various battery levels and the charges. Here the lead acid is the older one, the lithium ion, lithium polymer is a new one. You know the energy per weight, that means how much whatever given per the weight, it will be very high value because 160. Here the energy per volume, here also it is a high value, it is a 270. Power per weight, it is given very high value. Again the energy per cost also it will be very less. Here it is a 4 to 10. It is a cost wise it is higher. Something energy per cost is also very less. So the lithium ion battery, it is mostly used nowadays. So these are the comparison table for the various type of battery: lead acid, zinc, and lithium ion. Continuation of the batteries and chargers. We can charge the battery either through the household, that is the household power socket, and also to the charging station. What is the requirement of the charging system? The one good charger is always monitoring the battery voltage and also current flow and also battery temperature to safeguard the battery and also charging system. So how much voltage we are charging usually in the electric vehicle? Either 120 or 240. Another charging system is called a Magna charging system is available. What is a Magna charging system? It is a pedaling type, we will see later. So what is a charger circuit? You know, the charger circuit, we need the rectifier because we can get the AC supply, we are having the AC supply, that AC supply converted into DC supply using the rectifier. It is very, very important. Through rectifier, we can get the DC voltage. So the rectification is very important when charging that. That it is a simple circuit. We can have the AC, we can convert it to DC through the rectifier. After that, we can charge in the battery. It is a simple charger circuit. What is a Magna charging system? It is like a transformer. See, it is a mounted on the wall. It is called pedal. We can remove this pedal. We can insert into the car charging system. So this is one is a primary, another one is a secondary. The first half is called primary, second half is called secondary. So it will be removed from this system and it will be inserting into the car charging system. It will be charging. That's why it is a best inductive pedal. It is working based on the transformer. It is a Magna charge system. Next issue is the charging the battery. It is called equalizing. The electrical car, we are not having single battery to pull the car, but the electrical vehicle we are having series of batteries. That is the Stinga batteries. It is not possible to have all the batteries in the same characteristics. Even if you are having the, usually we are bank of batteries we are having is either one battery will be failure, usual process to change all the battery. But even if you are closely matched but not identical. So the weaker battery it needs more recharge. So that weaker battery it gets weaker. So we have to equalizing the charging system. For weaker battery we can charge more to ensure that all the battery charge fully. Ensure that all the battery charged fully. So this is taking more time to charge all the battery with a full condition. This is called the equalizing concept. Next very important part here, it is a braking. Here the braking, the normal car, we can apply the braking system. The heat will be wasted during the braking. That is a conventional braking system. But in regenerative braking, only regenerative braking we are not having, along with the conventional braking system. So here now, when you are the regenerative braking, the motor in the electrical vehicle, it is act as a generator. During this generating action, it can recapture the kinetic energy and also convert it to the electricity to recharge the battery. This is the concept of the regenerative braking. The next part is called auxiliary battery and DC to DC converter. What is an auxiliary battery? That battery is used for giving the supply to the radio, fan, computer, whatever the things, airbag, wiper, power windows, whatever the things operated using electricity, the auxiliary battery only provide the supply. For auxiliary battery, it is storing the power or voltage through DC to DC converter. So it is very important to charge the auxiliary battery. DC DC converter converts the voltage from main battery to 14 voltage. Suppose if you are having 300 volt, it will convert it to 14 volt and store it in the auxiliary battery. So the auxiliary battery is very important to implement in the car for operating all the items in the car, that is headlight, radio, fan, computer, etc. The next concept, how the electrification get it from the electrical vehicle is very important. So this is a conventional car diagram. The conventional car diagram with the fuel either petrol or diesel. It will be run the engine through this engine, through transmission system, the rotational power, that is a torque will be given to the diesel. Next concept is hybrid. In addition to the conventional engine, we are having the battery vehicle. Here the motor or generator, because it is an electrical vehicle. For running, it acts as a motor. For braking, it acts as a generator. Next, pure battery electricity. Only the battery system. There is no moving part. Here there are two engines. Here only the one rotating part. So the wear and tear losses also here reduced. Degree of hybridization. What is meaning a degree of hybridization? Suppose if you want to automatically stop and start the engine, stop or either the traffic here, it is called micro hybrid. It's called a micro hybrid. This is a micro hybrid. Here you know that it's an ordinary conventional car. We can stop, we can start the engine by applying the brake. Suppose if you are using regenerative braking, when we are using the regenerative braking, this is called the electrical vehicle automatically. Suppose if you are using the electrical motor to assist the combustion engine, that is called a hybrid vehicle. Once you can drive the car only using electrical motor, it is a pure electrical vehicle. So the next mild hybrid, that if you are using the conventional engine along with the battery, that is a Honda inside it has this facility. What is a mild hybrid? The micro hybrid only the engine. Mild hybrid it is electrical combined with the conventional engine, that is a Honda inside car, it has this facility. Another one can drive at time using only the electrical motor, that is a battery electrical motor, that is a fully hybrid. This is what is example of this car, Toyota Prius. The next one, we can recharge the battery in the wall out, extended car. What is mean? Recharging the battery in the sense it is called a plug-in hybrid vehicle. What is a plug-in hybrid vehicle? Whenever the battery charges are reducing, we can charge using charging station. That is called a plug-in hybrid vehicle. So it is available in the Chevy Volt. You know that the efficiency of the car will be increasing from micro hybrid to the plug-in hybrid. The plug-in hybrid is a very good vehicle. It is both a combination of conventional engine and also the electrical battery. So it is used for the, whenever the higher speed we can go, we can start the vehicle through the battery, and also we can run the vehicle through fuel when there is no braking system there available. Okay, next. Vehicle propulsion. What is a vehicle propulsion? We can increase the speed, we can increase the range. What kind of connections we are using? That is a serious connection. It will be assisting the power. It will be assisting, otherwise it is aiding the power. If you are extend the range, if you are extend the model, you can parallelly we are connected. If you are connecting the parallel mode, that means the battery vehicle and also conventional vehicle also combined. Next, dual mode. So this is a transmission system, this is a motor controller, this is battery, this is ordinary engine. So what is series configuration? The series configuration is that we are having the small fuel engine, so directly drive an alternator to generate the electricity. This electricity is stored in the battery. This is single operation or sent to the electrical motor. So electricity operated motor in the electrical vehicle, it is called a series system. It is a single system. When batteries are drained to a certain level, again engine will start and recharge the battery. You see, series engine we are having. Engine is used to run. It is a drive for the generator. The generator produces electricity. That electricity stored in the battery. Again, the battery will be connected to the motor. Through transmission, we are applying the kinetic energy. This is called series configuration. Next, parallel combination. There are two types of propulsion system. One is a electrical propulsion, another one is a normal propulsion. If it is a long trip, this kind of propulsion can be used for higher acceleration, for hills, we can use this. This is a parallel system. For parallel, we can use the engine to give the rotational power. Again, the battery given the power to the motor, again it will give the rotational power. Both are aiding. That is called a extended power. It will be given to the wheel through the transmission system. We have a parallel system. Comparison of these two one. In the series combination, engine never ideal because here only one engine, it will be running continuously. But not in the parallel configuration. Here two motors are using either through electrical or through the fuel system. And also here engine drives as a generator when the braking operation. Here the generator is available and the engine also available. Next, here variety of option in the mounting the engine, but here only one option because there are parallel system. This is the pictorial representation of the vehicle propulsion series. Here series system, we can use the motor, we can get the motor power from the battery through inverter. The motor rotation force given to the wheels. We are aiding the power through another engine. This is series connection. This is only one way to give the rotational force to the wheel. Suppose The engine give the rotational force to the wheel separately. This is a parallel system. That's all. Here the battery, it will give the rotational force through the motor, through inverter. Here another engine, it will give that rotational power through the transmission system. It is called parallel system. It's called a parallel system. So both series and parallel system, this will be the figure. So this both parallel and series combination, it is implemented in the Prius car and the Estima hybrid cars. Prius and the Estima hybrid cars. The next very important, how much energy loss in the ordinary vehicle and the electrical vehicle and the hybrid vehicle. You know, the normal conventional car or electrical vehicle, we are using the fuel like petrol or diesel. If you are giving the 100% fuel to the engine, so how much loss in the standby? What is called standby here? What is called standby? Standby in the sense for applying the braking, if you are stopping the signals, etc. What is the energy loss? That is the engine loss here, it is around 76%. Next, remaining 16% only goes to the drive line. The drive line in the sense to the running the vehicle. Then drive line losses is around 13%. Remaining 13% only goes to the transmission system. Then the transmission system, only the 4% is goes for running the wheels, and 3% goes for aero, that is for this is the power train diagram or vehicle diagram of the energy loss, the city driving. City in the sense we are applying more braking, we are stand at the signals, we are having more money, stops and the starts. So this is the diagram represents how much energy lost the city car drive. When it is the same car in the highway driving, here the standby loss is 0. We are getting 19% of the power after drive line. Here the 7% is used for running, 10% used for turning. Then braking we are using 2% because the highways we are using less time of braking at all. So this is the highway driving energy loss. This is the hybrid system. Here, hybrid system, we are using fuel. You know the standby loss, it is 8%. Earlier, we are seeing the degree of hybridization, automatically stop, automatically start. This is called micro hybrid system. Earlier, we are seeing the degree of hybridization. This will reduce this 8%, micro hybrid vehicle. Then next, we go for braking. If you are utilizing this braking energy, again fed back to the supply, it is called a mild hybrid. It is called a mild hybrid. So the mild hybrid vehicle reduces the braking losses. Again, if you are go for the fully electric and also plug-in hybrid electric, if you are go for the plug-in hybrid electric, the engine can be replaced by the only battery operated vehicle. That is a fully hybrid vehicle, plug-in hybrid vehicle can eliminate engine entirely. So if you are go for increasing manner of the hybrid vehicle, micro to plug-in hybrid, we can eliminate the engine entirely. Here only using the battery and also the motor. That's all. So if you are eliminating the engine, we can reduce the 76% and this 8%, this 6%, we can get more power from the input. It is very important. So this is called the electrical vehicle energy loss. Suppose if you are giving the batteries 100%, the motor it will take 90% of the battery power, 10% to the loss in the motor. Again 90% go to the drive line, some losses in the drive line. After losses in the drive line, 76% goes to the driving, that is a transmission system. This 76, around 35 is go for running, 29 go for turning, that is aero, 11 is used for braking operation. This is the energy loss diagram of the electrical vehicle in the city driving. Next. So again, this is the energy loss diagram. Next one is well to wheel. What is meant by well to wheel? Here we are having the fuel, either petrol or diesel, whatever it may be. Having taken the petrol or diesel from the ground, it will be used directly to the vehicle, how much we are utilizing. Again, using this fuel, we are generating the electricity, how much it goes to the car. So these are the comparison of the both the system. One, if you are using the diesel, that is a diesel engine, whatever the engine, it will generate 33% of electricity. After losing of 6% in transmission, we can get the 31% of the electricity. You know that plugged wheels 76. Earlier you see here the 76%. Here it is a 13%. So 76% in 31%, it's around 23% of electricity is given to the electrical vehicle. When you are not using this diesel directly to the car, we can convert into diesel fuel input as a power generation, and if you are generating the electricity and through transmission, after that if you are charging the electrical vehicle, we can get 23%. Again, if you are getting the diesel or petrol directly, this refining, after refining we can get 82%. After transmission we can get 80%. Here pump to wheel it is only 16%. Then how much percentage you can get it? Here only 13%. You see the efficiency, we can use the fuel directly through refining and transmission of pump to wheels, it is around 13 to the car. Here, we are converting this fuel into electricity, again fed to the car, it is around 23%. So comparing these, electricity give the more percentage and efficiency to the car. So this is called well to tank. Well to tank. This is called tank wheel. This around 23%, it is around 13%. So being electrical vehicle, the efficiency from raw fuel to the car, it is around 23%. If you are raw fuel to the car directly, it is around 13%. So how the electrical, that is a plug-in electrical vehicle works? You know that already I told the plug-in electrical vehicles both a combination of diesel or petrol with the battery. The initial we can start the electrical vehicle using the battery, and for a long run we can go for the diesel. Here you see for 0 speed to some other kilometer we can use electrical vehicle, used as a electrical vehicle. After long run we can go for the fuel. This is the best choice for the plug-in electrical vehicle. Some of them plug-in electrical vehicle charging system is a wall mounted. Earlier I told the Magna power system, like that it is the charging plug, that is socket. They are 110 volt or 220 volt AC. Here it is the terminology. So many terminology is available in the electrical vehicle. The state of charge. What is the state of charge? It is represented as a battery capacity, the percentage of the maximum capacity. Next, Depth of discharge. It is a depth of discharge in the sense the percentage of the battery capacity. How much it will be discharged. Next, the capacity, the capacity of the battery in ampere hour. Then energy, it is the total whatever available when the battery is discharged at a specific current, specific energy. That means per unit mass, how much whatever it will be developed. It is also represented in the comparison table of the various battery. Again, the specific power. That is the maximum power that the battery can provide per unit mass. That is called a specific power. Next, benefits of the electrical vehicles and the plug-in electrical vehicles. You know that the electrical vehicles are more efficient. The diagram it shows if normal vehicle it gives a 13%, electrical vehicle gives that 23%. The fuel cost is comparatively very low, and also emission is very less. That means a pollution free. That simpler transmission. We are generating the supply. We are charging the battery easily. That moving parts are very less. The electrical vehicle, the fuel choice is only one choice. It is electricity. Then independent of the energy. That means oil, fuel. Next, emissions are improved with the time. That means it is give the less emissions, and also the emissions at a few large locations. It is easier to control using the electrical vehicle. The next, coming to the point, it is the vehicle to grid communication. What is a grid communication? Only if you are using the electricity, you can allow the communication is with the utility and the vehicle. It's very important. And also integration of the more renewable like wind, solar, so many things it is allowed. Then only we can get the power from various sources. The used electrical vehicle can be used as a stationary battery for other utilities. And also we can show the much focusing on energy efficiency that will reducing the electricity sales and the expensive renewable energy generation mandate. The electrical vehicle would be a welcome of a new segment for the utilities. And also batteries could provide the ancillary services. What is ancillary services? It will provide the supply to the various equipment in the electrical vehicle. Also another advantage, if you are using the daytime, you can car. For suppose if you are ideal in the night time, using wind power generation, we can charge the battery through the peak wind power production. Next, challenges. What are other challenges? Here the challenges in the sense challenges regarding battery. First, limited range. The range of the car it is limited due to the battery size and weight. It is very important. Next challenges, it will have a long charge time, and also it is a very high cost. Then the battery life is a question mark. The battery life is not reliable. It is also one of the challenges. The consumer can accept because of the aware of the electrical vehicle. It is a danger one for the battery failure. Next, grid integration. The grid integration is not so simple. We can have more charging station. The charging station facilities in India is very less, and also it is not completed now. Next, addressing the customer perception. What is addressing customer perception? They will accepting the limited range. If the range will be increases, the cost will be very high. Why they are accepting the limited range? The most people can drive the car less than 40 miles per day. Another one, they are keeping the car almost 20 to 23 hours ideal in the daytime. Next, the smaller vehicle, it will give the reduced performance. The performance are very less. But in the last 30 years, here the improvement gone for increasing vehicle size and performance, but they are not reducing the consumption. So the smaller vehicle, the limited range, these are all due to the cost of the electrical vehicle. Another very important point is battery. The earlier they are using lithium, nowadays it is recommended for lithium ion and the nickel hydride batteries. It is a rechargeable battery. It is a recycling, it is 90% recoverable. It will give the extending battery life, but it is very, very costly also. Next, considering the cost. Its initial cost is very, very high. So most of the companies they sell cars, but they are not produce a battery, they are lease the battery. So lease is like a power purchase agreement. It is creates the vehicle cost will be very high. And another one is charging infrastructure. The charging infrastructure also is not good for the electrical vehicle nowadays. It is very, very important. Next, the comparison of the battery electrical vehicle, hybrid electrical vehicle, and the fuel cell electrical vehicle. You see what are all the parameters we are comparing? Propulsion. What kind of propulsion motor we are using? Here electrical motor only used because it is fully battery electrical vehicle. Here electrical motor and the IC engines because it is hybrid, both the normal electricity and also to the fuel. This is a fuel cell. Here only the electricity we are using, so electrical motor drives. Then the energy system. How the energy system? It is a battery only, ultra capacitor. Here battery, ultra capacitor, internal combustion engine generating unit. That is called a fuel operated engine. Here the energy system is a fuel cell only. Here what is the energy source and infrastructure? It is a charging facility only needed. Here fuel station we needed and the charging facility also needed. Here hydrogen we want, methanol, gasoline, ethanol, it will be needed for the energy source. What is the characteristics? Here pure electrical, it is a zero emission. Here hybrid vehicle, it is a low emission. Here also pure electrical, zero emission. It is independent on fossil fuel. Here purely dependent. We also independent of the fossil fuel. The battery electrical vehicle commercially available. Here also commercially available. But fuel cell electrical vehicle is not commercially available. Even it is a high energy efficiency, it is under development. Future only it will come. What is the major issues? The limitation of battery, dependence on fossil fuel, high fuel cell cost. The fuel cell electricity system, it is very, very costly, and also it is a lack of infrastructure. Here you see it is hybrid electrical vehicle, the battery electrical vehicle only nowadays it is in the scenario. The fuel cell electrical vehicle coming in future. What will we keep forward regarding electrical vehicle? In 2022, almost 10% of the vehicles sold will be battery electrical vehicle. It is our objective by all the governments. What is the price? Internal, if it is very high compared to the internal combustion engine, considering plug-in electrical vehicle, considering electrical vehicle, this much of cost will be higher than compared to the normal conventional machine. This is also one of the major factor for not purchasing electrical vehicle. So even government is providing the incentive for the two-wheeler and all. Then long-term plug-in electrical vehicle will beat out the hybrid electrical vehicle. It will take some time. And it will also dominate a battery vehicle also, battery electric vehicle also. So 30 to 50% reduction in the fuel consumption by 2035. It is said by the Haywood. It is one of the American car manufacturer owner. So another vacancy told 47% reduction by 2030. These are all the feature looking forward of using the electrical vehicle. So this is one of the Tesla electrical vehicle. It is a two-seated. You see the top speed is 125 miles per hour. It's a dollar in term $110,000. You know the range it is a 244 miles. That's the speed. Other electrical vehicles available with different rates with different year. This is a Vishwakarma plug-in electrical vehicle, the Tesla model. heavy volt. This is also plug-in electrical vehicle. It is also in the 2022. It will be renamed as a volt electrical vehicle. Another one is Mitsubishi, Think City Cars, Nissan Leaf, Apteras, so many type of electrical vehicle. So many company, Ford, Nissan, Smart, and many others, they are developing the electrical vehicle. The Massachusetts Institute of Technology, they are having the electrical vehicle team. They are producing the electrical car and the electrical bike. They are having the research team. They developed more concentrate on the electrical vehicle. Here you see the battery in the two-wheeler. They found in the 1985. They developed the race cars. And also they placed second in the 10th World Solar Challenges. You see this website, you can go for the what are all the solar electrical vehicle team under the development. Again, continuation of this, one more thing I want to explain again. Have you seen the PPT, the plug-in electrical vehicle? So many model with the company names. It is a 10 to 20 electrical vehicle miles. This is a 40-60 electrical vehicle miles. It is 80 to 100 plus electrical vehicle miles. This is a plug-in electrical vehicle model. This is extended range electrical vehicle model. This is a battery electrical vehicle model. These are the company product name. Prius, Honda Clarity, Chevrolet Volt, Cadillac ELR. So many cars are developed with so many companies. These are all the other battery electrical vehicle. Tesla model, Nissan Leaf, Smart Forward, so many types. These are all the battery electrical vehicle. Volkswagen e-Golf, Tesla Model S, Tesla Model X, so many. Fiat also they are developing 500e, Lucid Air, Force Mizani. So many types of electrical vehicle developed. The battery electrical vehicle. This is a plug-in electrical vehicle. Toyota, Prius, BMW, Honda Clarity, Volvo, BMW 330, 740, Mercedes Benz, Hyundai, so many company, Mini Cooper. So these are all the various model of plug-in electrical vehicle car types. Another one, what percentage of new car sales are projected in the electrical car 2025? You may think around it is a 10%, either 5 or 10% only. Again, what the reason for not purchasing electrical vehicles? These are the very important slide. Availability of chargers. Charging station is very less. Another one is battery range. If you are increasing the battery range, it will cost more, it will occupy more space, etc. And also cost. Remaining all very less. Lack of knowledge, technically not proven, performance, practicality, limited choices, safety. These are all the very less percentage. What is the reason for not purchasing electrical vehicle? Availability of chargers, battery range, cost. The cost. These things are very, very important, but not recommending the electrical vehicle purchase is very important. Then next, forecast. What is a plug-in electrical forecast? A plug-in electrical vehicle forecast, it will be 2022, it may be increasing. But earlier, this is 2020. For the least time of 10 years only, the electrical vehicle car will be increasing in nature. Here you see battery improvement. What is the vehicle purchasement? These are all the ordinary vehicle. These are all the powertrain. These are all the battery. These are all the gasoline car. So what is that? Internal combustion engine ordinary vehicle with the battery vehicle. So what is the range we are using? 2016, again you see the gasoline car is outdated in the 2013. They are only go for the battery electric vehicle. Here the driving range, it is also increasing. It is also this is a charging station of electrical vehicle. Then it is mostly the charging access. Nowadays they are 80% of charging at home, but it is not safety one, but they are using the 80% charging at home. Remaining 20% only in the charging places. Next, what are the EV charging types? AC charger, DC charger, fast charger. So many charging facilities are available. These are all the plug point models. Here the 6 miles per range per hour. Here 24 miles per range per hour. That is 120 volt. If you are running a 6 miles per hour. If it is a 240 volt with 3.3, 6.6 kilowatt, it is a 24 miles per range. If it is 480 volt with 44 kilowatt, we can run 150 miles per hour. These are all the EV charging types. Another one is carriage ready. What are all the types of plugs available? If it is 130 volt, it is a plug model. If it is a 240 volt, it is a plug model. These are all the model available. Then public charging station type, dual port, and fast charging station. These are all the diagram of the charging station plug. Next, charging station app. The app is giving the indication where after 20 kilometers, after 15 kilometers, we are having charging station like that. What are the available station? What is the star charging notification? Everything is available in the charging station app, like a Google Map. Like a Google Map. These are all the scale of public charging station. If in 2040, definitely the public charging station will be increasing higher. Increasing higher is very important. You know, scale up of home charging, it will be increasing in 2030. Home charger in 2020 is less, but 2030 it may be increasing. Home charge plugs. This is called a scale of public charging station. That is a charging station. So these are all the survey. Next, light duty vehicles provide the opportunity to reduce CO2 emission. The CO2 emission is only due to the transport only, not industry, residential, commercial. So the transport only it is very, very high. So that only we go for electric. Only we go for electrical vehicle. High potential. Yeah, that also the light duty vehicles, car, two-wheeler, tri-wheeler, etc., etc. These are all the ACPL energy generation carbon free. That's all. These are all the other model of car. That's all. Any queries?
Participants, any queries?
Hello, sir.
Any clarifications?
Hello, sir.
Yes, sir. Yes, sir.
எனக்கு டவுட் இருக்கு. கார் சார்ஜிங் ஸ்டேஷன் வந்து பப்ளிக்கா வந்து இப்போ ஆர்டினரி கன்வென்ஷனலா இருக்கிற மாதிரி பெட்ரோல் பங்க்லாம் இருக்கு இல்லையா சார், அதெல்லாம் லைசன்ஸ்
ஆமாங்க.
வாங்கி
ஆமா.
இப்போ ஃபியூச்சர்ல வந்து இந்த மாதிரி பப்ளிக் சார்ஜிங் ஸ்டேஷன் வைக்கணும்னா அதுக்கு நார்ம்ஸ் ஏதாவது ரெகுலேஷன்ஸ் ஏதாவது இருக்காங்களா சார்?
இப்போ இருக்கிற வரைக்கும் சார் இந்தியா பொறுத்த வரைக்கும் அவ்வளவு நாம்ஸ் இருக்கு, பட் இங்க எதுவும் பண்ணல அவ்வளவா. அதுதான் பிரச்சனை. இப்போ ஃபாரின்லாம் இருக்கு ரெகுலேஷன், ஸ்டாட்டூட்டரி ரெகுலேஷன்ல இருக்கு. இப்போ பெட்ரோல் பங்க் இருக்கிற மாதிரியே இங்கே அவ்வளவா பண்ணல எலக்ட்ரிக்கல் வெஹிக்கிள்ல. இப்போ நீங்க டூ வீலருக்குலாம் பண்றாங்க, உனக்கு ஃபோர் வீலர் அந்த மாதிரி இருக்குன்னா அவ்வளவு இதுவா வரல. அது ஒரு நமக்கு ஒரு பிக் டிராபேக்.
ஓகேங்க சார், தேங்க்யூ.
ஓகே சார்.
Sir, good morning, sir.
Good morning, sir. Good morning.
Sir, myself, Dr. Velmurugan from Uttayam Engineering College.
Oh, it's okay, sir.
Thank you for a nice presentation. We gained a lot of information from your PPT, sir.
Okay, sir.
But actually, sir, my doubt is still we are lacking with electrical vehicles technology. Am I right, sir?
Yes, 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 sir.
But how to overcome these things, sir? Since riding with fuel vehicles and riding with EV vehicles definitely will show a lot of difference.
Yes, sir, yes, sir.
But actually, it is practically possible to use that vehicles, especially for long traveling, sir. Of course, the research is still going.
Okay.
Is it okay, sir? That is useful for people?
Which electrical vehicle?
Yes, sir. Yes, sir. Yes, sir.
Yeah, with the safety precautions, it is useful, sir. Even
Okay,
if you
sir.
are not giving some safety precautions, electrical vehicle. So
Okay.
most people are aware of that is a battery failure. You know, ordinary car, the gas-fired car also, the battery will be damaged, it will fired. Always in
Definitely.
automobile, fire only due to battery only. So, okay, the safety precautions will be strengthened. Then only the usage of electrical vehicle coming into the existence. It is not given more. Even foreign they will do the more production. The cost wise it will be very high.
Yes,
But
sir. Yes, sir.
nowadays, yes, the cost, affordable cost of the people will be very less. That is according to GDP, the affordable cost very less. So that only they are not preparing. That's the point.
The cost
Even
of the cost of the electrical vehicle also one drawback, sir.
drawback. Another one, even if you are using the if ordinary bike, we can have that definitely after 15 years you cannot use it. That's the rules there. But
Yes,
they
sir.
are extending their usage by what is called the fitness certificate. Fitness certificate. Somebody using 25 years the single bike. That's not good. If you see
Anyway,
Delhi,
we'll hope that the future may be with the electrical vehicle.
definitely, definitely. But it will be 2030 or 40. I don't know actually.
Okay, sir.
But
Okay, okay.
it may come definitely.
Okay, sir. Thank you. Thank you for your information.
Thank you. Thank you, sir.
Sir, any other clarification, sir? Shall we wind up the session, sir? Thank you. Thank you all for your patient listening. And I thank our HOD sir for their wonderful presentation. Thank you all. Sir,
Thank you,
close
madam.
பண்ணிடலாம் sir.
Close madam. Thank you, madam.
Okay.
Thank you.
Thank you, sir.
Thank you, sir.
Gauri madam, what is the time for next session?
Sir, by 11:30, sir.
11:30. Okay, madam.
Yes.
Thank you. Thank you.
Thank you, sir. Thank you, sir.
Excuse me, ma'am.
Sir,
What's participant ID, madam?